For topic 5, we're going to start our discussion on functions. Okay, we talk about it kind of early because they could show up from now until the end of the semester. All right, so nothing to be alarmed of about. A function is just a different way of expressing a relationship between two quantities. Okay, so we're hopefully at this point becoming very accustomed with showing a relationship between two quantities x and y with our equations and two variables. A function is just a special way of doing that. Now, there is criteria that has to be met for an equation to qualify as a function, but once we know it qualifies as a function, then we can go ahead and use what's called function notation, okay? It's just kind of like the way we represent an equation to tell the reader, hey, we acknowledge that this is a function. All right, so some definitions. All right. When elements in one set are associated with elements in a second set, we have what is called a relation. Okay. So any set of ordered pairs would be considered a relation. Okay. And this is kind of like the perfect time to talk about this because we've been talking about ordered pairs, right? We've been talking about sets of ordered pairs, which happen to be solutions to equations in two variables. So all of our equations so far are at the very least a relation. Okay. Now, the elements in the first set are called the input values, and those would be the elements of the domain. So for us, when we're talking about our ordered pairs, we're going to let x be the elements in the domain. Okay, so for us, the input value, we would call this the independent variable. It is the x coordinate, those x values. That's the set called the domain. Okay. Now, the elements in the second set, those are going to be considered the output values. Those are the elements of the range. And for us, we're going to say that the y coordinates or the dependent variable, those would be the elements in the domain. Okay, so we have a relation, which is just any kind of association between two sets. Okay, so ordered pairs would qualify as relations because we're looking at how x's correspond to y's. Further, all of our equations in two variables meet the criteria to be a relation because any set of ordered pairs is considered a relation. And remember, the solutions to an equation in two variables are the set of ordered pairs that satisfy that equation. Now, when we're looking at our set of ordered pairs, all of the x coordinates, those are considered the input values, which make up the domain. And then the y coordinates, those we consider the output values, those make up the range, okay? So input for X, output for Y. You will also sometimes, let me go back to the black ink. You will also sometimes see the X coordinate called the independent variable. And the Y coordinate will be called the dependent variable. So you can kind of think of it, Y depends on X. So Y is going to change based on how X changes. Don't get too bent out of shape about independent and dependent variable. If this was a kind of a tougher, higher level algebra class, we would get more involved in that. But for now, just understand X, input, domain, Y, output, range. Okay? Now, if you have a certain type of relation, we can then call it a function. Okay, so we're getting ready to define function. So a relation, when each member of the domain corresponds to exactly one member of the range, that is when we have a function. Okay. So what we need to know about a function, what that definition is saying for us, when we look at that function as a set of ordered pairs, the x coordinates cannot repeat. So I'm going to underline it, outline it, and put a star beside it. Okay. So for a relation to qualify as a function, we have to have a situation where each input corresponds to only one output, meaning x coordinates cannot repeat. Okay. So if that criteria is met, then you can say your equation is a function. Okay. Otherwise, it's just a relation. All right. For example 9, it says determine whether each relation is a function, state the domain and the range. Okay. So what we're looking for is would x's repeat? Does an x correspond to more than one y? Okay. Now, in this first example, we just have kind of like little information bubbles. So we have states and their senators, and I have no idea when this information was pulled. This is definitely an old example that I remember using a number of years ago. So this information is probably outdated. Doesn't matter. The idea is the same. So we have Indiana, and its senator is Dan Coates. Washington, Maria Cantwell. North Carolina, Richard Burr. Oregon, we have Ron Wyden, I guess. I'm not sure how you say that. And then Jeff Merkley. So notice here, Oregon has two senators listed. Okay. And then for Maine, we have Susan Collins. So the question is this a function? So is it a function? And the answer here would be, well, no. Okay. No, this is not a function because Oregon corresponds to two different senators. Okay. So if we think of this as our input value, those would be our X's, and we think of senators as our output values or Y, then we would see that Oregon, if you type in, like imagine a machine where you could type in an X value, a state, it would spit out the senator. Well, in this case, if we type in Oregon, it spits out two senator names. Okay. So this would not be representative of a function. Now, what is the domain? The domain is the set of all input values or the set of your X coordinates. So for us, we usually start with squiggly brackets. We would list the states. So Indiana, Washington, North Carolina, Oregon, and Maine. That would be our domain. That's the set of the input values, okay? The range is the set of the output values. So we would have Dan, Maria. Notice I'm on a first name basis. I'm not, I'm just joking. Anyway, it gets late and I don't know, I stop caring and then I say stupid stuff. All right, so for the range, we have Dan, Maria, Richard, Ron, Jeff, and good old Susan. Okay, so that would be our range. All right, so that's really all there is to it. When you have a relation, look to see if your x's repeat. If you have repetition in your x's, you do not have a function. And then the domain is all of the x values and the range is all of the y values. Okay, now typically speaking for us, we would see domain and range problems with more like generic ordered pairs. So we have the set of ordered pairs, -2, 6, -1, 3, 0, 2, 1, 3, and then 2, 6. Now, if you wanted to do the little information bubbles, you could. You would want to list your x's. I'm going to need to make that a little bit bigger. So we have -2, -1, 0, 1, and 2. And then we have if I go in order, we have 2, 3, and 6. -2 goes to 6. -1 goes to 3. 0 goes to 2. 1 goes to 3. And 2 goes to 6. Be careful with this one. It does not say anything about y's repeating. Y's can repeat. That is absolutely fine. When you're dealing with a function, what makes a function is the fact that each input corresponds to only one output, meaning x's cannot repeat. Y's can repeat all day long, x's cannot. Okay, so is it a function? Well, yeah, it is. There's no single x value that has more than one arrow coming out of it. So as long as each x only has one arrow coming out of it, you're good. You meet the criteria for it to be a function. Notice our x's were -2, -1, 0, 1, and 2. There's no repetition. So this is definitely a function. The domain is going to be the set of all x values. You do generally write them in order, smallest to largest. I'm not going to like lose sleep if you don't, but that is the proper way to do it. So we would go -2, -1, 0, 1, and 2 for the domain. And then the range we had, you don't have to list each individual, I don't know how to say that. You don't have to list a range value for each domain value. You want to list each unique range value. So 2 only gets used once, but 3 and 6 repeat. You don't have to write 3 and 6 twice. So we would just want to write 2, 3, and 6. And that's it. That is kind of what is a relation. X coordinates, remember, are input values or our domain. Y coordinates are the output values or the range. And for a relation to be a function, each input value can correspond to only one output value, which means x's cannot repeat. We have an example of something that is not a function, and then we have an example of something that is a function. In the next video, we will look at functions as equations. So we will do something called function notation, and then we'll look at graphs and how you can really, really quickly tell if a graph is a function or not.